Okay, so today we're going to learn how to evaluate logarithms. Bonus point. What does it mean to evaluate an expression? Solve? I'll give you a point for it. It's not quite it. But what does it mean to evaluate something? Okay, I'll take that. That's not still quite what I'm looking for, but I'll take it. So usually in mathematics, what evaluate means is they've given you like a function of some kind, and they're going to give you an input, and you want to find the output. So that's it. So we're gonna do that. We're gonna take a log expression, and we're going to evaluate them. But we're going to come across some issues here because there are some things that we can't do if it's not base 10 or base E, okay? Because those are right on our calculators. Sometimes you could do logs without base 10 or base E by hand, but even that's kind of limited, and you'll see what I mean as the lesson goes along. But so for instance, here's an example of something that until today, unless you remember your Algebra 2 class really well, and your Algebra 2 class got to this, you would not be able to do something like this. Okay, so that's kind of the objective there. So let's begin. Now you guys don't need to write this, but I want you guys just to kind of think with me here for a second. Log base 4 of 16. What does that equal? This one you can do. It's 2, right? Good. We know it's 2 because 4 to the second power equals 16, right? What about now? What we sometimes come across is maybe some other things too. Like let's say I had this log base 4 of 8. Now this one's a little bit harder to do, okay? But we could technically still do this by hand. Okay, so let me remind you really quick. I could put an x here, right? And then what would this be in exponential form? 4 to the x power equals 8, right? Now the reason we can do this by hand is because we can do what here? We can change the bases to match. All right. What base can I get so that these are both the same? 2. So I can change this to be that, and I can change this to be that, right? Drop those out, and I can solve it. So we can do quite a few different problems with this, but if I were to give you guys something like this, you're going to run into a problem. The one I showed you earlier, like log base 3 of 10. You could set that equal to x. You could write it in exponential form if you wanted to, but there's no way we're going to get those bases to match, right? That doesn't mean there's not an answer. It just means we don't know what the answer is. So what we're going to learn today is what happens when you come across a type of logarithm with a base that cannot possibly match the argument, and therefore we can't do it by hand. Well, we're going to use our calculators, but the issue is our calculators only do base 10, and they also only do base E. They don't do any other base. So what I'm going to do is I'm going to show you guys a new formula called the change of base formula. It's a formula that will allow you to change this logarithm into a new logarithm with the base of 10. You could do E, but we're just going to do base 10. So we can actually use our calculators to get the answer. Okay? So that's the idea. Now, let's go ahead and begin the process here. So I wonder if I should just do this with numbers first. I think I'll just do it with numbers first. And then I'll give you guys a formula. Let's go ahead and stick with this. you don't, once again, you don't need to write this. Just kind of follow along with me here. Okay, so as a student, like right now, let's say I don't have solved this. So what I would do then is I think, okay, well, let's go ahead and change it to exponential form. Maybe that'll help. And then we realize, no, that's not going to help me either. I'm not going to be able to get those bases to match, right? Okay, well, this is where we kind of start pulling in some creativity. We like base 10, don't we? So check this out. What I'm going to do is I'm going to log both sides. Now, what base is that I'm using? That's a base of 10. When we don't write the base, that's a base of 10, right? So that's good. Why would I want to do that? Well, I can use my properties from the last two lessons that we've done. According to our properties, what can I do with this x? I can put it in the front, right? And what can I do to get x by itself now? We could divide both sides by log 3, right? What do you mean? Yes, it is algebra. Why is that? Is that a problem? You mean one of the properties? Well, the only property that I used was the fact that from yesterday was that power goes to the front, and that's it. That's the only log rule we used. But you're right, the rest of it was algebra. But look, now I know what x is. Come back up here. Remember I said this equals x? Now I have a new expression for x with logs that have what base? 10. And now my calculator can do this for me. I can just use my calculator to do log of 10 and divide it by log of 3. So now I'm going to give you guys a shortcut here so that you don't have to figure that out every time. Here it is. So let's say that well, let's go ahead and actually title this. This is where you guys want to start writing. Change of base. Okay. Call it formula because. Okay, so let's say that we have a log with some base of a, and we don't like that because our calculators don't have that base of a, right? But our calculators have a base of 10, correct? So what I can do is I can use a base of 10. I'm going to take this number and put it on the top, put another log on the bottom, put that number on the bottom. Those are equivalent expressions. Remember on the algebra I showed you, remember how we got x by itself? We divided? That's fine. That's where that division comes from. Now you don't so much need to remember how I solved that. You could. I think that's kind of a neat thing to know. But this is what you guys are going to need to know. Okay? So now we can solve weird problems like this. So let's do a quick little example here. How about log of 310? So that's going to be log over log. Which number goes on top? 10. The 10. And which one goes on the bottom is the 3. So on your calculators, I want you guys to do, hey, good morning. Second. To do log 10. Close your parentheses. Okay, so after the 10, you should have a parenthesis closed. And then push divided by log 3. Close parentheses and then equals. You guys should be getting something about 2. I'm going to just round it to 2.1 there. 2.1. Okay. You might have forgotten to close your parentheses after the 10. You have to do log 10, close your parentheses, and then divide it by log 3. All right, so there's our answer. Now, if you wanted to check your work, you could, okay? Remember how we said this would be? So I'm telling you right now that this is our answer there, right? Now, what would that be in exponential form, you guys? 3 to the equals 10. Now, it's not going to be exactly right, but it's going to be close. So try it on your calculators right now. Type in 3 to the power of 2.1. 10.045, so it's really close, right? So there it is. So now we can do problems like this that we can't do by hand, right? Using the change of base formula, okay? And so now we can answer really weird questions like, what power would you have to raise 3 to in order to get 10? Well, 2.1, and it's thanks to this guy here. It's the change of base formula, okay? So let's do one more example just to make sure you guys have got the general idea down, and then we'll let you guys practice one. So here we go. I'm going to call this example 1. I'm just going to say evaluate, save some time. Okay, so there's no way we're going to get those bases to match. Okay, 5 is only going to ever be able to be 5, and 200 is not a power of 5. Okay, so there's no way we're going to get those to match. So we're going to need some help with our change of base. So change of base is going to be log 10 on the top, log 10 on the bottom. And which number goes on top? And which number goes on the bottom? And then we're going to go ahead and calculate it. So I'll let you guys help me out with that. Go ahead and do log of 200. Don't forget to close your parentheses. Divided by log of 5. What can you say it to me? How much? 3.29. We agree? And you don't have to do this, but it's a nice way to check your answer. I know that that's right if I do 5 to what power? I know that we're right if that gives me something pretty close to what? 200. And we could check that on our calculator. Does 5 to the power of 3.29 give you something pretty close to 200? So it's close? Good. All right, so we're good. So you don't have to do that, but it's helpful. All right, so I want to throw one at you guys real quick, let you guys practice it. Go ahead. All right, so Malak, log what on top? And how about on the bottom? We're going to put 2, right? And then we'll see it. Always here today. Amber, what did you get for your answer there? 5.32. Good. All right. And this is kind of me just throwing it out there so you didn't have to do this, but I want to see, John, if I wanted to check this answer, how could I check it?
You can check it by dragging the base, that's it.
Okay.
And having it go to the power of 5.32.
Okay.
And the answer you would get is 39.9.
And is that good? Because that's close enough to 40, right? So there you go. So that's the change of base formula. All right. Let's go ahead and move on to some other problems here then. So example 2. Now what we're about ready to do, it's going to seem a little bit repetitive, but it just looks different. So I want to make sure you guys are getting used to seeing the question being presented in a different format. But it really is the same question. Oops, that's not what I wanted. So, believe it or not, it's really just the same question. It's being presented differently, okay? So I'm asking you to think of this log expression here as a function, and then it says find f of 5. And what does that mean when there's a little number in the parentheses next to the 5? 6. I'm sorry, what did you say next? That's what x equals. So we're going to plug that in for x, right? So basically, f of 5 then is that. And so there's no way we're going to get those bases to match. They're completely different bases, so we need the change of base formula. So it's going to be, which one goes on top? 5. Okay, now so far in the examples we've been doing, it's always been the bigger number on top, right? But that's not how it works. The number that's here is the one that goes on top. It doesn't matter if it's bigger or smaller than the other one. And then 6 goes on the bottom. Okay. The way that I remember that is, you know, when you look at these two numbers, this one's already on the bottom, right? So it stays on the bottom. That's kind of how I remember it. All right, and then from there we go ahead and calculate it. Has anybody got that one yet for me? 0.89? Okay. And that answer makes sense because what power would you have to raise 6 to in order to get 5? Well, 6 to the first power is 6. That's too big, so it's got to be something less than 1. So 0.89 makes sense. All right. And I just want you guys to keep your wits about you for the next two here. Oh. Well, I wanted to present it as a function, so just a second. Alright, so go ahead and write both of those ones down and we'll okay, so let's go ahead and begin here. So now I'm looking at this function. I want to find f of 80. So that means I'm going to plug 80 in for x, right? So f of 80 then would be log of 80. Now before I calculate it, I'm just going to leave it like that for now. Over here, what's this one going to equal? ln of 13, right? So now here's my question. How am I going to do this? That's a log base 10, right? And how about this one? This one's a base of what? That's e. Yeah, natural base is e. Now, you could do change of base on these, and you'll get the right answer. But you don't need to. Why not? These are already on your calculator, right? so you don't need change of base. So keep your wits about you, save yourself some time. All you have to do is punch in the numbers. So I'm out of space here, but I'll let you guys add it on your notes. What is log of 80? All you have to do is push log 80 equals. What do you get? 1.903. And how about ln of 13? Which one, John? 2.56. So write your answers down there on your paper there. So you don't have to use the change of base formula if you've already got bases that are on your calculator, right? The only reason we're doing it is for weird bases that are not 10 or 8, okay? So there's a little bit of a decision-making process there. Now, but could you do the change of base? I mean, check it out. If you guys had this, if you had log of 80 and you just were kind of off your game, you thought, okay, what's a base to 10? I remember that, and you did this. There would be nothing wrong with that. Oops, just 10 there. There would be nothing wrong. You get the right answer. Okay? It's just that you're kind of wasting your time. So I'll throw some at you. The goal here is you have to decide when to do change of base and when not to, and also kind of get used to that function notation stuff that I'm reminding you about here. Oh, this is student practice 2. Supposed to say a G there. All right, so you have a good day. Thank you. Which problem requires the change of base?
Number 2.
Number 2 requires the change of base. Good. Here's a fun one. Which one doesn't even require a calculator? Anybody? Yeah, let's go to Sam. Number 3 doesn't even require a calculator. We'll talk about why that is in just a second. Okay. So for the first one here, f of 2 is ln of 2. ln's already on your calculator, so you just punch it right in. Okay. So I'm going to ask Ashley, what did you get for your 0.69? And that hopefully makes a little bit of sense to us. Okay. If we write this in exponential form, what's my base? E. And I'm raising that to power of what? And that should be something pretty close to 2. Now, why does this make sense? Well, you got to remember what E is. You remember what E is approximately? Huh? It's 2.71, but yeah, good, you're pretty close. So 2.71 is bigger than 2, right? So whatever power we raise it to would have to be slightly less than 1 in order to give us a value of 2. All right, so as for the next one there, I think at this point we already know change of base fairly well. So there's that, but we would have to do change of base on that one, okay? So I'll show my work up here. You should have did log 25 over log 3. And Joaquin, what did you get for your answer for that one? 2. 2.92, do we agree with that, guys? 2.92 sound good? I don't have space to write it, so I'll just take that. As for this last one here, we would write log of 1,000. Now this doesn't require even a calculator because this is base 10. We can get these bases to match. 1,000 is base 10 raised to what power? 3. So you don't even need a calculator for that one. But if you wanted to, you could have just used a calculator. I would tell you the answers. Okay? All right, last thing I want to go over with you guys here for the day. Example 3. More of the same kind of, but just kind of taking it up a notch. Not a huge deal. All right, so suppose I told you that f of x is equal to log base 2 of 5x minus 1. Okay, so for this one, f of 3 then, we're just going to plug 3 in for the x, right? So that's going to be 15 minus 1, which is what? 14. And just do your change of base, right? I'll bring it back. So at this point, we would observe, okay, I can't get these bases to match, so I'm just going to go ahead and do my change of base formula. So it's going to be log base 10 of 14 divided by log base 10 of 2. And then we just punch it in our calculator, and we have our answer. 3.81. I think you guys are going to be okay with that one. The next one, I think, is going to make you think a little bit more. Okay, but so for now, I feel like we don't need to stop and practice that. But if you disagree, let me know. Let's go ahead and take a look at another one. This next one will be a little bit different because it's going to have some numbers on the outside. So, for instance, let's see. Let's say g of x is equal to negative 2. Log base 3 of 7x plus 2 plus 5. And we want to find g of 4. Okay, so the issue is going to be this. It's that we have numbers on the outside also. So what we're going to do is we're going to figure out what this is first. And after we get that figured out, we're going to multiply it by a negative 2. And then add 5 to it after that. That's it. Let me say it again. So we're going to do this first, figure out what this is first, by plugging in 4, right? And then we're going to multiply it by negative 2, whatever we get. We're going to take that answer and multiply it by negative 2, and then we're going to add 5. So that's the plan. So here we go. G of 4 is equal to negative 2 log 7 times what? 4 plus 2 parentheses plus 5. All right, so anyway, so we plugged it in, right? And so this is going to be 28 plus 2, which is 30. Oh, did I not put a base on here? I did. I've been not writing it. Shame on me. There should be a 3 there. All right. If there wasn't a base there, the problem would become a lot easier because then it would be base 10 and I just use the calculator, right? But for now, here's what we're going to do. So check this out. This is where things get a little bit weird. So pay close attention to this step. This, we need to do change of base, right? Because our calculator can't tell us what this is because it's in base 3. So I'm going to change that to base 10. Okay, so that's the main step of this problem. The rest of it should naturally flow. All right, so here we go. Log 30 divided by log 3. And once again, we're just going to have to round it because it's always going to be some weird funky decimal. So log 30 divided by log 3. And I'm getting 3.0. I'm going to round to 3.1 because if I try to round to the hundredths place, it just bumps it up to a 10, which makes the tenths place a 1. And then from there, we just follow through with the basic math there. So we're going to order of operations, right? You do multiplication first. So 2 times 3.1 is going to be negative 6.2. And then I'll just use my calculator to add 6.2 and 5 together. You could actually just do the multiplication and addition right on your calculator. And so I'm ending up with negative 1.2. Okay? So most of it kind of just flows naturally from things that we already know. But the thing that I really want you guys to note here is how do you transition from this step to this step? That's the main part right there. That piece becomes a change of base formula. Okay? Any questions on that one?
Yes, really.
What's up?
You know, here for the second period.
I guess so.
It's cold outside.
Okay. Oh, that's right. You don't have a first period. Huh? Right. Okay, so let's do a student practice. I think we're on 3, aren't we? H of x is equal to 5 log base 2 of 4x minus 3 minus 9. And I want you guys to find h of, let's do 8. And that's it. So we seem to be doing pretty good out there with this one. I'll walk you through it just in case, but pretty much every paper I came by had it. So we had 5 log base 2 of 4 times 8 minus 3. 4 times 8 is 32. Take away 3 would be 29. Next, we are going to do our change of base on this thing here. Right? And then I believe we're getting about 4.86 for that. Is that right? Huh? Okay. And then we multiply. What does that come out to be? 20 point what? 24.25 minus 9. And then we get 15.25. Okay, sounds good. So there it is. All right, so that's the end.